Hi, my name is Christine G, and I am going to be going over this problem. Here we have, we're going to be testing the null hypothesis that the mean is 100 versus the alternative that it's not. We have this simple random sample of 19, and it's obtained from a population that is normally distributed. So here we're asked the first question. We're given some information, the sample mean as well as sample standard deviation, asked to compute the test statistics. So here we can do this easily in StatCrunch. So we pull this open and go into Stat, T-Stats, and this is a one sample test with the summary data. And then we know the null hypothesis is that the mean is 100, and the alternative is that it's not 100. And then 104.5 for the sample mean, and sample standard deviation is 9.3, and the sample size is 19. So then we can easily compute this. And here we have the t statistic as 2.109. Okay, that's good. And then now it asks us for the critical values at an alpha level of 0.01. So the critical values, they have the table here, or we could go into StatCrunch. So let's go ahead. We know this is a two sample test, and we know that because right here it says the mean does not equal 100. So it could be down in the left tail or the right tail. So it's not a one-sided test. So here we can go into Stat, Calculator. Put this over here. Oops, Calculator, and then we go into T. So this will give us this T distribution. So here we're told that it's 0.01. So let's go ahead and take a look at what that means. So let me just grab here, and we know that it's normally distributed. So when they're telling us that we know a couple things here. We know that this is a two-tailed test because we know that the alternative, or they're calling H1, is mu does not equal 100. So it's not a single-sided test, as I mentioned. So either if we get way down in this tail or way down in this tail, we can reject the null, which is mu equals 100. So here we're given that the alpha level is 0.01. Well, that has to be divided. Part of it's here and then part of it's here. So if we divide this by 2, because this is completely symmetric, then we get 0.005 for each tail. So we want the critical value that are associated here and here. So we can go in and look that up here. So we have right now this shows half, or 0.5, 50%, but we just want 0.005. And then the degrees of freedom, that is 18. So this would be the critical value, this negative 2.878. So let's go ahead, and that would be the cutoff where you would reject if you were further away from the mean than that. Let's see, so the critical values are the negative 2 point, I forgot it, pull it up again. Negative 2.878. And something important to note is that that is for the 2.878. I'm sorry, I keep forgetting. 2.878, and then this one would be the positive 2.878. So they're asking us to put these in order. 0.878. Okay. Let's see if that's right. Looks good. And then draw a t-distribution that depicts the critical region. Which of the following critical regions in the t-distribution? So of course it would be this because it's two-sided. This one you would just reject if it was way down in the right tail, and this one in the left tail. So let's try that. Okay, will the researcher reject the null hypothesis? So let's take a look at this. We have some good information here. This is these are the critical values, and then our test statistic is 2.109. So let's take a look at that. 2.109 would be someplace, let's say around here. So it's closer to the mean than, and it's not in the rejection area down here in the tail. So we would not reject the null. Let's go ahead and take a look at that. So the researcher will reject, nope, will reject. There is not sufficient evidence for the researcher to reject the null hypothesis since the test statistic is not between the critical values. So there is not sufficient evidence for the researcher to reject the null hypothesis since the test statistic is between the critical values. So let's take a look at that. That looks good. And we can go back here and see the test statistic. Oops, let me pull that back up. Is, let me draw in red, is here. So it is between these critical values. It's between these two. So closer to the null, it's than either of the critical values. So we would not reject. So that looks good. Hope this was helpful, and thanks so much for watching. Please feel free to contact me for any questions you have. Thanks. Have a great day.